Let's introduce the concept of the Thevenin theorem. For any one-port network with independent sources, linear resistors, and linear dependent sources, and any kind of their complicated connections, it can be equivalently replaced with a serial connection of an independent voltage source whose value is the open circuit voltage of the port, and a resistor whose value is the input resistance with all independent sources set to be 0. By using the circuit element symbol, any kind of the complicated one-port network can be equivalent to such a circuit. Let's prove it. We've discussed the equivalence before. Two equivalent circuits means the equations that describe them have the same many parameters. Now we try to prove that the left circuit is equivalent to the right circuit. Well, we write out the port voltage and current equation in the right circuit first. According to the KVL, U equals minus Ri times I plus UOC. We want to prove this circuit has the same form. The port voltage and current's reference directions are shown in the figure. We can connect a current source to the network in this way. The current source value is I. What's the voltage of the current source? Now we use the superposition theorem to solve the problem. How to use the superposition theorem? There are two steps. Firstly, when all the independent sources inside the network take effect and the current source doesn't take effect, the subcircuit is like this. Secondly, when the current source takes effect and all the independent sources inside the network don't take effect, the subcircuit is like this. The network is called P, including all the dependent sources and resistors. U double prime is the voltage of the current source. What's the value of U prime in the subcircuit? It's obviously the open circuit voltage of the original circuit. Let's look at the second subcircuit. It's just the circuit we use to measure the input resistance by placing a current source across the terminals of a network with no independent sources take effect. That is I to U method. U double prime is equal to minus Ri times I. The minus sign is due to the non-associated reference directions of the voltage and the current. The current flows in this direction, and the voltage direction is positive up and negative down. According to the superposition theorem, we can add them together. U is equal to UOC minus Ri times I. Do you find that these two equations have the same forms and parameters? Thus, we've proved that this circuit is equivalent to this circuit. The value of the current source I is arbitrary. In other words, it's applicable for any value of the current. So the equivalence is applicable for any value of the current. Now I have a question for you. Of course, the left circuit can also be equivalent to the network when connected with a voltage source U. Then you can find the current I. What's the solution for the current and what's the equations? Please think about this question and find out the equivalent circuit accordingly.